morning, everybody. We are starting with chapter 13 of the real estate course, math portion of the real estate course. You know that the real estate course is made up of chapter 13, chapter 14, chapter 16, chapter 17, and then we have the arithmetic type of math, which is the math for the city, municipality, and the statements of adjustments. Okay, so the math that's requiring the HP calculator, the HP 10B2 plus calculator, is chapter 13, 14, 16, and 17. So we'll go through that. First, let's take a look at how to set up the calculator. When you buy the calculator, okay, make sure you have only one zero here, and the way to do that is take second function, the red function, and press equal sign and then the decimal sign. Okay, that's going to give you 10 only. That's what it does, is it's going into what's called the scientific notation. It's going into how many zeros are required. Okay, so if we take a second function equals and put a 3, that means 3 zeros are going to come after the decimal point, or it's going to be 3 numbers are going to be coming. Let's say I do a calculation. Let's say I say 0.3654 times 2.368. Okay, since we had a setting of 3 decimals there, the final answer is just going to be given as three numbers after the decimal. We don't want that. Actually, we want the full screen. But if we do the full screen, it's always going to look confusing. So if we do a second function equal with a decimal, that will also give you the full screen. So it's better to have that. So let me just say, press second function equal decimal, and that will give you 10, and that's what we want. Okay, so the interest rate in our calculator is the most difficult part in this course. Okay, so it's we use the symbol capital J, and capital J stands for the interest rate per year, and we're going to use the nominal button. Nominal is the interest rate at any compounding period. So at this time, just bear with me. I'm using a lot of terminology that you will understand later. Okay, so this is nom right here. So this is what we're going to use as our interest rate, not the I per year. Okay, we're going to use nom. So if we want to put in 13%, you say 13, and you don't need to use 0.13, just 13, and you use second function and here. Okay, if you want 5%, you go 5, second function, nom. Okay, if you want 2.5%, you go 2.5, and second function, nom. That's how you put in interest rate. Okay, so now n is a time period. Let's say we're talking about 5 years, you go 5 and then you put in n. Let's say you're talking about 3 years, but you want months, so that would be 36. That goes like this. Okay, PV is the amount of money that you have right now, or money that you're investing today, right now. Okay, let's say you're investing $350, then you say 350 goes in PV. Okay, so let's say you're going to save $2,000, okay, or $200,000. That would go as a PV right there. Okay, then PMT stands for payment. Payment is over the time period of your loan or your investment, how much more money you're contributing or how much money you're taking out. So let's say you're taking out $250 every month. So if you're taking out, I know taking out means negative, but we're going to think of negative as anytime you go deposit. So let's say you are getting money, that means you would just do that. Okay, if you were getting $3,500 every month from the bank, you would just put in that. Okay, if you were depositing, let's say $2,500 every month, then we would use a negative part here, negative decimal, see that, and then put in the payment. FV stands for what you have at the end of the year, how much money, or not at the end of the year, but at the end of the time period. So let's say you have 2,500 at the end of the year, that would go at the F. Let's say you have 300,000, so you would put in 300,000, that would go FE. Now let's say you make a mistake. Let's say you wanted 3.5, but there's a mistake. You can use the back. Let's say it was supposed to be 3.57. So this back arrow is very useful. And the last most confusing button on our calculator is what's called P per year. It should be CP per year, compounding periods per year. Okay, so this button right here is right under the PMT, P per year. So again, it's a second function. Let's say you wanted to show one compounding period, so you would go one, second function, done. Let's say you wanted to show two compounding periods, you would say two, second function. Let's say you wanted to show quarterly compounding, 4. Let's say you wanted to show monthly compounding, 12. And last one, let's say you wanted to show daily compounding, that would be a 365. Okay, so that's how we use our calculator. Let's start with the first calculation. Okay, let's do a question. The way we're going to, first of all, set our calculator is second function. Okay, we're going to clear it. If we clear, press clear, it's clear screen, but get used to pressing second function, then the clear. That means it's clearing everything in the memory also, which we don't want, previous questions, okay? So we're always going to be drawing a timeline diagram. This is today. This is payment, meaning what's happening in this time period. This is at the end, how much money we will have. And at the top here, top of the timeline, we're going to write the interest rate and the time. Okay, so this is how we're always going to set up our questions. From a big paragraph full of information, we're going to get this timeline diagram, and then we're going to bring in our calculator and do the calculation. So first thing I'm going to do is put in the 1. This number 1 tells you one compounding period per year. So one compounding period is done like this. Next thing I'm going to do is the 10%. That's the 10, and it's going in as nominal. And this is the hardest step of this math course. Okay, let's do that again. Let me show you again. First thing we do is put in this tiny little subscript number. This stands for how many compounding periods per year. So it's 1. It says 1. Just take that and put that there. The 10%, that's the J value. That's the nominal value right here. That needs a second function button. So anytime you want this red stuff, you need to press the second function. Okay. So next we look at this calculator and go work towards this way. Okay. We don't look at the timeline diagram. We look at the calculator to see what's needed next. First step, we need N. We look at our diagram. N is 5 years. So N is 5. Done. We've already done this part. We go to PV. We look at our calculator and say we need PV. We look at our diagram. PV is 50,000. So 50,000. PV. Next, we look at PMT on our calculator, and we look at PMT on the diagram, 0. Next, we press FV is what we're looking for, and we press FV, and we get $80,525.50. This minus, bear with me for a few more minutes, or a few 10, 15 more minutes. We'll go into what that negative is all about. For now, what you need to know is what this diagram says is you invested at 10% compounded annually for 5 years. You invested $50,000. Then you come back 5 years later, there's $80,000 in that bank account. Okay, let's do another question very similar to that. Okay, this time we are investing $60,000. So really we could take, because everything is already in this calculator, this is already in there, this is already in there, this 50,000, let me recall PV, it's 50,000 from the previous example, okay? What's in the N? Let's recall N. Okay, that's 5. So we could redo the entire question, or we know there's only one change, and that is your PV. And what are we looking for? FV, press FV, and that will give you 96,000. So if you take 60,000, invest 60,000 for 5 years, at an interest rate of 10% compounded annually. 1 means compounded annually, 10% per annum per year. The end result is you will have $96,000 in your bank account. Don't worry about the minus for now, just hang in there for a second. Now, if I want to redo the entire question, let me redo the entire question. First thing is 1 for the compounding period. Second thing is 10% for the nominal rate. It's called nominal interest rate per year. Okay. Next, I'm going to look at the calculator and go this way. N. I need N. N is 5 years. I look at my diagram. N is 5 years. I've already done the interest rate. PV. PV, look at the diagram, 60,000. PMT, look at the diagram, it's 0. Here, oh, look at the diagram and the calculator. We're looking for FV, so press it. 96,630. Let's do another example. Okay. Okay, the next example is, this time it's 80,000. So quickly, if you wanted to just do it quickly, because we know all the other answer parts are still the same, so the answer is 128. But I'm going to start all over because I really want to get used to learning how to use this calculator. Chapter 13 is more about using the calculator. Chapter 14 gets more depth and so on in chapter 16 and 17. So let's do this question again. Interest rate, 1 compounding period per year, and 10 for the interest rate, which is nominal. I need to go to second function. Now I go to N. N is 5 years. Interest rate's been done. PV, look at my diagram, it's 80,000. PMT, payment. Payment means what's happening from this time period to this time period. This is today, and this is 5 years later. Well, nothing, according to this diagram, nothing's happening. No money's being deposited, no money's been taken out. So 0 for payment. And at the end, final value, 128,000. Good. Let's do another example. Okay, so this time I'm going to clear the calculator again, clear all. Okay, if I clear all, recall N, nothing there. Recall PV, nothing there. All that's been cleared. Okay, if I was to just press the clear button, all those things would still be there. Okay, so always clear all, see all. To get see all means second function there, clear everything. Okay, so now I'm going to do this question. 1 for the compounding period, 10 for the nominal interest rate. Now N is 5 years. PV is 90,000. Payment is 0. Looking for FV, 144,000. Great. Let's continue. Do another example. Okay, clear. Okay, watch if I recall N, it's there. Recall interest rate, it's there. Recall PV, it's there from the previous example. If I just press clear, it's still there. Recall N, still there. Recall interest rate, still there. Recall FV, still there. If I want to do a new question, I should always clear the memory of the calculator. So that means press see all, second function there. Now if I recall N, it's not there. It's all gone. That's a good idea to do, because good thing to do, otherwise you'll have other numbers from previous examples in there and it could make errors on your arithmetics. Okay, so let's do this one again. Compounding period is 1 per year. Interest rate is 10 per. Nominal rate, meaning nominal means interest rate per year for any compounding. For this, we'll talk more about this later, but at this time, just put it in as nominal rate. N is 5 years, done. You'll be always confused if you keep looking at the diagram and say, what should I put in next? It's better to look at the calculator and go this way. Okay, put in the P per year first, periods per year, put in the nominal second, then work from this step all the way this way. Okay, so we've already done N, we've already done this. PV, look at the diagram, it's 50,000. Okay. Also now we have 10,000 per year. We're also putting in. Okay, so let's put 10,000 as our payment per year. There. And now at the end we have $141,000. Okay, let's continue doing another question. Okay, what we have in this situation is we are saving $20,000 per year, and we have 50,000 now. So how much money will be in our bank account after 5 years? Let's do that question again. Clear all. One compounding period per year. Interest rate is 10%. N is 5. PV is 50,000. Payment is 20,000. Payment doesn't just mean how much we pay. Payment could also mean how much we go put in the bank account. Okay, we'll talk about negatives and positives in a few minutes. But for now, just get used to using the calculator. And PV was 50,000, not 20,000. PV is 50,000. Payment's 20,000, meaning we're depositing another 20,000 into the bank account. And at the end, we have $202,000. Okay. Let's go to next example. Let's say we have a question here. And the question is, if you invest $200,000 today at an interest rate of 4% per annum, compounded annually, what will be the value of this investment after 5 years, rounded to the nearest $10? So from all of this information, we will be able to make this diagram. Okay, so how do you make this diagram? First, you make the timeline. Then you get the 200,000, put it in as PV, which is today. Then interest rate is 4% with a J1. Annually means 1, okay? 1 compounding. 4% is over here, and it's 5 years. Put that over here. And what's happening? There's nothing happening in this time period, so you can put PMT as 0. So how do we do this question? Let's clear all. First thing we're going to do is put the interest rate, 1 compounding period, and 4% interest rate. Time is 5 years. This one's done. PV is 200,000. PMT is 0. And at the end, FV comes out to be 243. Don't worry about the negatives at this time. Think about what this question is saying. You invest $200,000 today. How much will you have in 5 years? Well, if you invest 200, there'll be 243,000. Okay, let's do another question. Okay, this time you're investing $300,000. And now we're changing the interest rate. We're changing the interest rate, and the interest rate is still 4%, but it's compounded semi-annually. We'll figure out what the difference between semi-annually and annually is, okay? Semi-annually means twice a year, 2 times a year. So this number is a 2. So let's clear all. Again, you take all this information, okay, and you chart it up here. You know this is 300,000, okay? You know the interest rate is 4%. Semi-annually means 2. And you know it's, say, 5 years. Now, we're not talking months yet. We're talking semi-annual. There's a mistake right here, or they're giving you this just to confuse you. 5 years. We know it's 5 years, but because we're talking semi-annually, we need to think about N as how many periods there are in 5 years. So if we're talking semi-annually, 2 periods per year, that means there's 10 for N. N is 10. N is not a 5 this time. Okay, let's continue. So this is there to confuse you. We're not talking months yet. But if this was a 12, yes, then we would need months. So let's do 2 compounding periods. 4%. N now is a 10. 10. Think of birthdays. 5 years If you had a birthday every 6 months, semi-annual means every 6 months, that means you have 10 birthday parties. Okay, 10 birthday parties. So N we've done, interest rate we've done, PV is 200,000. PMT is 0. And at the end, we're looking for FV, 243,798. And to the nearest tenth, that means to the next tenth, that would be about 700, that would be $800. Okay. Let's do another question. Okay. So what we have here is we're saving 50,000, okay? And also we're going to save another 10,000 per month, okay? This time the interest rate is with a 12 here. That means 12 compounding periods per year. Every month, that means every month compounding, something's happening, okay? So let's do this question. Clear all? For 12 for the compounding period. Okay, chapter 13 is all about learning how to use the calculator. Don't stress out too much about what does J12 mean and why are we changing this to months. For chapter 13, half of chapter 13 is learning how to use the calculator, getting good at it. Okay, let's clear everything here. Okay, so first thing is 12 compounding periods and 10 for the interest rate, second function. Now we go here and say, look at the drawing, and drawing says 5 years, but we're really talking about 12 compounding period. We're really talking about months. So we need 5 years, 5 times 12, 60 for the months. We need 60. Done. This has been done. PV is money today, 50,000. PMT, we're also saving another 10,000 every month. At the end, FV comes out to $856,000. Okay, now we're going to look at the symbols. Now we're going to look at symbols, what symbols really mean. If we need to organize ourselves, we're going to have in our system, or math system for chapter 13, 14, and so on, if you look at the system of money, anytime money's going out of your pocket, it's going to be a negative, okay? Think of money going out of your pocket as negative, okay? So what we have in this picture is $100,000 is going from your pocket to the bank now, today, okay? So 100,000 is going out of your pocket. You're saving 100,000. So if you're saving 100,000, that means you must be going to the bank and putting away 100,000. Also, you're saving $1,000. So that's also going to be a minus, okay? And then the plus number, if the answer comes out to be a plus, that means that's money you're going to get from the bank. So let's do this question. Again, 12 for the compounding periods, 10 for the interest rate. Time now, think of time. If we're talking about 12 compounding periods per year, 5 years is not, we need months. We need our time in months, and that is going to be a 60. This one's done. PV, we're putting away $100,000. Putting away means minus, not this minus. Don't use this minus. This minus here, negative. Okay, PV. Also, we're saving $1,000 every month. That's also a negative. And we press FV, and notice it comes out to be a positive. That means that's how much money the bank is going to give us. Whenever someone gives us money, that's going to be a positive number. So when we get a loan, that's someone giving us money. We're going to use positive number. When we invest, that means we give someone money. We're going to use negative number. Okay, let's do another question. Okay, so we're doing a question now. In this question, we are getting a loan of 50,000, and we want to know how much do we have to return to the lender after 5 years. And in that 5-year time period, we don't give any money to the lender and we don't take any more money from the lender either. Okay, so let's do this question. Clear all. First thing we do is put in the interest rate, 12 compounding periods per year, and the interest rate is 10%. Now we go to N. Look at the diagram. N says 5 years, but we're talking 12 compounding, so we're talking about months, 12 months in a year. So this number is going to be a 60. Interest rate's been dealt with. PV is 50,000. Now, are we going to use positive or negative? Well, we are getting a loan. I am getting a loan of 50,000. That means money is coming to my pocket. So yes, I'm going to leave it as a positive. I don't have to press positive, negative. Leave it alone. So let me do that again for you. First thing, interest rate, compounding period 12, interest rate, nominal rate 10%. N is 5 years, but we need to convert into months, 60 months. Interest rate is done. PV is 50,000 loan. That means someone gave me the 50,000. I know it's a debt, but I know in some systems we think of debt as negative numbers, but this is money coming to us. So 50,000 came to us, and for the 5 years we didn't take any money, we didn't give any money back, and at the end FV, that means we have 80. Negative means we owe $82,000. $82,000 is going to be owed. Okay, minus means this money has to be given to the lender after 5 years. When we answer the question for the exam, we don't have negatives or positives. So we answer the question in English. So the answer would be, we owe to the lender $82,265.45. Okay. Okay, this time we have a loan of $300,000. How much to return after 5 years? Let me quickly do that for you. 12 for the compounding periods. Interest rate is 10. 5 years, we're talking months. 60. PV is 300,000. Loan, that means someone gave us money. And no activity in the 5 years. Payments, nothing. And FV comes out to be 493,000. Minus means we owe this money. Negative means we owe, after 5 years, we owe $493,000. And answering the question, we don't look at negatives and positives, or we don't answer it with negative or positive. We answer it that we owe $493,000. Okay, let's do another question. Okay, this time the question is, we have a loan of $300,000 and we get a further loan of $2,000 per month. Okay, we started with a loan of $300,000 today, and we get a further loan of $2,000 per month. We want to know how much money would be owing. So think of this diagram right here. We quickly draw the diagram like this, and we keep it the same way. We put the PV on this side, FV on this side. Okay, interest rate on the top, time period in the middle of the time line, and the interest rate and the payment right here. Keep it the same way. Okay, you notice we have 1, 2, 3, 4, 5, 6 things here. And what we're doing now to learn how to use a calculator, we're always finding the FV. But this calculator lets us figure out 1 out of the 6 things. Whichever is missing, we can figure out. If we know the other 5, now we know this 1, 2, 3, 4, and 5, we can find the 6th. If we had this and we wanted to find this calculator will allow us to do that also. We'll do a few questions later on with that. So let's do this question quickly. So what do we have? We have a interest rate. Don't put this in first. Don't start N here. Don't do that. So put the compounding periods as your number 1 step, nominal rate as your number 2, then work from here this way. You notice if we had FV and we were looking for PV, we would skip PV and go here, and then come back and press this as the answer. We'll do questions for that also. Okay, so compounding periods per year, 12, so that means we're talking about months. Okay, interest rate, 10%. N 5 years, but we're talking months now. This 12 tells you 12 compounding periods per year. That means every month something's happening. So this time period has to be in months. So 60 for the months. Interest rate's been dealt with. Loan, we got a loan of 300, so it's positive. There, we don't touch this button. There, oops, sorry, mistake. This needs to go here. Oops, mistake here. Okay, let me do that again. 300,000 PV. Okay, payment 2,000. That means we're getting a further loan. Okay, that means someone's giving us 2,000 more every month. Normally we make payments for that loan, but this is just to learn the calculator. We're getting a further loan of 2,000. That means positive. At the end, we would owe 648. Now be careful. Let's say we were paying 2,000 back every month. Watch what happens. If we're paying 2,000 every month for this loan, then we don't owe 648. We only owe 338,000. See the difference? So let me do that question again. If we get a loan of 300,000, which is PV, that means someone gave us money, and we're getting another further loan of 2,000 every month. That means money's coming to me. I would owe them after 5 years 648. But if we are getting a loan of 300,000, which is PV, and we're making a payment of 2,000, which is negative, then we would only owe them 338. See how the negatives and positives work? We have to keep track of all that negative and positive. Let's do another question. Okay, so here, okay, this situation now, we have a loan. We got a loan today for 300. Now we're making a payment to the lender of 200,000. We already did that question previously, but let's clear everything and do that now. So we make this diagram. Interest rates given to us, time is given to us. We make this diagram. Okay, very important that you make the diagram. Don't go from here to the calculator, because then you're going to be wasting a lot of time and you're just going to be guessing. Now you're not guessing. Now we know exactly what's needed. Okay, so first thing is interest rate. Compounding period 12. Interest rate 10%. Time period, we're talking months. This tells us 12 compounding periods per year. We're talking months. We always have to work with this. Whatever this says, if this is 12, then this has to be in months, and this also has to be in months. Okay, these two units have to match up. All three, 1, 2, 3 units have to match up. This tells us what units to use. Okay, so we're going to use 12 compounding periods per year. That means we're talking months for this question. Okay, so let me clear all this and do that again. So 12 for the compounding periods per year, 10 for the interest rate per year, N is 60. Interest rate's been dealt with. PV, we got a loan of 300,000. Now for the payment portion, it says we're making a payment to the lender of 2,000. That means money's going out of our pocket every month, 2,000. So 2,000 is going every month out of our pocket. That means this number is negative. Done. And at the end, there. Okay, that means 338,000 is still owing. 338,000. This negative means we owe 338. Let's say instead of 2,000 every month, let's say we were giving them 20,000 every month. Let's say we gave them 20,000 every month. So recall PV, if recall payment, this says we're going to the bank and giving, or we're going to the lender and giving them 2,000. But let's say we were giving them 20,000 every month. What do you think FV is? FV is now positive 1 million something. You see the difference? If we give them only 2,000 every month, then we still owe them 338,000 because interest also. Okay, interest also. But if we gave them $20,000 every month, they would owe us money because we've given them so much extra from the loan amount. Okay, let's do this question this way. Okay, let's try this one. Okay, so if we give them $2,000 every month, then we owe them $338. Let's say we gave them $3,000 every month. Obviously, we should owe less than $338. That number is now, 3,000. Let's give them 3,000 every month. Then we would only owe them 261,000. Let's say we gave them 4,000 every month interest, 4,000. Then we would owe them after 5 years 183,000. We gave them 5,000 every month. Oops, not 50,000, 5,000. Then we would owe them, okay, let's do that again, 5,000. We would owe them only 106. Okay, let's say we wanted to know how much we need to pay them here so that there's no money owing at the end. Well, that means we need to change this to FV to 0. That means we don't want to owe them any money. How much money would it take every month to make it so that this number is 0, meaning we owe them nothing? Well, we put in 0 for FV, and then we press this button. We're looking for this. We need to pay them about $6,300 every month. Then we would owe them no money. Everybody okay with that? Let's do another question. Okay, this question here, we are looking for how long, if we deposit $100,000 in our bank account, that negative means we went to the bank and deposited it, we want to see $200,000 in the bank account. If we deposit $100,000, we want to know how much time we have to wait until an extra $100,000 is in the bank account. Okay, let's do that question. Interest rate. So this is kind of like a question of how long will it take to double my money? Okay, so first thing is interest rate, 12 compounding periods per year, and interest rate is 10%. Now we're right here, but you notice we're looking for N. From our diagram, we see that we're looking for N, so skip this, don't put anything in. We've already done this. PV is 100,000. Negative, that means we went to the bank and we deposited that. We're not doing anything in this time period. We should have put PMT equals 0 here, but let's put 0 for PMT. FV is 200,000. We want to have 200,000 come to us afterwards, not negative, positive. And we're going back and say, looking at our diagram and say, what are we looking for? We're looking for N. So we go back here and say, there's my N. 83. What is that? 83 years or 83 months? We're doing months. This question right here is in months, right? 12 means months. That's months. If I wanted to know that in years, you could divide by 12, and that will tell you approximately a little bit less than 7 years. Okay, let's say we wanted to do this question. Let's say we wanted to know how long will it take to triple my money. Okay, triple my money. So I've started with 100,000 and interest rate is 10% compounded monthly. Let's do this question. Okay, so 12 for the compounding periods and interest rate is 10%. Time is what we're looking for. We're looking for N, and when we press N at the end, it's going to be in months. This is already done. PV is 100,000. And 0 for PMT, even though we didn't write anything, we should have wrote 0 for PMT. Make our diagrams well so we can follow the diagram and the calculator afterwards. FV is 300,000. And the end answer, we're looking for N, press it. That's about 132 months, and divide by 12 if we want years. That comes out to about a little bit more than 11 years. A little bit more than 11 years. Okay, let's do another question. Okay, we are going to do what's called an interest-only loan. What is an interest-only loan? Is the payment of this loan is only interest portion. Okay, we're going to keep whatever we borrowed. Okay, 50,000 means we got a loan, positive number here, 50,000. That means we still owe 50,000 at the end of that time period. And this time period is irrelevant. It could be from here to here, or it could be from here to here. Because every month we're paying the rent for this money. We're paying the interest. Interest is rent for money. Okay, we're not putting more, we're not giving them more than interest, and we're not giving them less than interest. Okay, interest only loan is for an interest only loan. The question on the exam will not tell you to put positive here and negative here. You have to know that we're going to put 50,000, and we don't need the positive symbol. 50,000 here. We have to use the negative portion of the same number, negative of the same number. We draw the diagram. Okay. This time, be careful. The interest rate is given as a 1 compounding per year. 10%, but 1 compounding per year. So N hat will stay in years. We're talking years. And this payment is per year now. We cannot do, unless this number is a 12, then we can talk about months. But this number is given to us as a compounding period of 1. We have to stay. Yes, we'll learn how to change this number into a J12 later, but that's chapter 14. With this chapter, we're just learning how to use a calculator. So we've got our diagram. From all this information, we make our diagram. And first thing I'm going to do is 1 for the compounding period, 10 for the interest rate. N is 5. We keep years now. We're talking years. This is done. PV is 50,000. And payment, we're looking for payment. So leave it alone, skip. And 50,000 also for FV, but this time a negative for FV. And what are we looking for? We're looking for payment. There it is. Well, our payment's $5,000 per year. So every year we have to pay $5,000 at the end of, or at really on the beginning of the next year, we have to pay $5,000. So what's our last payment? Last payment would be the 5th year. It would be my 50,000 that I have to return plus the 5,000 for the previous year interest. So 55,000 is my last payment. Okay, let's do another question. And this time again, it's an interest-only loan, and we are looking for the payment. Okay, and the interest rate that's given to us is J2. J2 means, J means interest rate per year. The little 2 means 2 compounding periods per year. That means payment will be every 6 months. There will be 2 payments per year. So let's figure that out. First thing, 2 for the compounding periods and 9 for the interest rate. N, this time N, it's a 5-year loan, so how many payments will there be total? 10 payments. And interest rate is done. PV is $50,000 loan. And I'm looking for payment. Here's the time saver. If FV is going to be the same as this number, but the only difference is it's going to have a negative, so you just put a negative and press FV. Bit of a time saver. And we're looking for payment. This number is every 6 months. We have to work with this too. Yes, there is ways of converting this into J12, but we're not going to get into that yet. Take the interest rate that's given to you on the loan and work with that. So this is $2,250 per 6 months, not per month. Okay, $2,250 per 6 months. And your last payment will be $50,000 plus the $2,250. Every payment will be $2,250. Every 6 months, $2,250. On your exam, they may ask you, what's the 3rd payment? What's the 2nd payment? Or what's the 5th payment? Okay, that's the answer. Now, notice if we were to take this loan and convert it into, let's say, a 3-year loan. Let's say 3-year, instead of 3 years now, instead of 5, it's 3 years. So this will be a 6. That does not change the payment. The payment is still the same. This loan can go from here to here, or this loan can go from there to more. it makes no difference because every 6 months you're paying the interest. So if it's 1 year, let's say it's a 1 year loan, so that means N is 2. You notice the payment is the same. Okay, let's say it's just a 6-month loan. That means one period. Still same payment. Okay, sometimes they will, on examination, they will not give you the time. You can put in 1 for N, and that would be your answer. Okay, let's continue. Let's do another question. This time we're given J4. J4 means quarterly. That means every 3 months you'll be making a payment. Every 3 months. Quarter of a year means every 3 months. Okay, so it's interest-only loan. Again, they're not going to tell you that the interest-only loan means that you have to put positive and negative here. You have to know that. So let's clear that. 4 compounding periods. 8 for the interest rate. N is now 5 years, so it's a 20. Even though N, if we put N any other number other than 20, it'll still be the same answer. They may not even tell you what N is on the exam. So this has been done. PV is 50,000. And FV is also 50,000, but with a negative. And we're looking for payment. There's main payment. It's $1,000 every 3 months per quarter. Per quarter means every 3 months. 4 times per quarter means 4 times in a year. Okay, but think of it, it's every 3 months. So all the payments are the same. Every 3 months, $1,000. So if the exam question says, what's the third payment? The answer is $1,000. Okay, you don't need to worry about figuring out. The payment is the payment. It's the same amount every 3 months. Okay, what's the second payment? $1,000. How many payments? According to this loan, 20 payments. What's the last payment? $51,000. Okay, now let's take a look at time period also. If the loan starts on June 1st, if it's a 5-year loan, it's going to be 1995. Okay, if it's a 5-year loan. So this is incorrect. It should be 1995. And the last payment would be May 31st. Your exam questions do not go into last payment. They do go into how much is the last payment, but very rarely have I seen anything which says when will the last payment be. Okay, let's take a look at another question. Again, interest-only loan. Interest-only loan, let me clear the calculator. We are told that the interest rate is J12, meaning 10% per annum, compounded every month, compounded 12 times in a year, every month. So 12 for the compounding period, and the 10 for the interest rate. You notice we're always doing everything the same steps. We've done the compounding period first and the nominal rate second. Now we go from here and we look at the diagram, say N. N is 5 years, which is 60 for months. This has already been done. PV is $50,000, which we got as a loan. If it's an interest-only loan, we need to return $50,000 after 5 years. And payment is going to be $400 per month. All the payments are the same. How many payments? 60. What's the second payment? 416. When is the last payment? Or what is the last payment? 50 plus 416. Okay, don't worry about when is the last payment. Okay, let's go to the next question. Another type of loan is called interest accruing loan. Different from interest only. Interest accruing is where we make no payments, 0 payments. 0 meaning we owed them every month. We owed them interest, right? But we're not paying them. It's not illegal. There are people, lenders, who will give you interest accruing loans. Construction loans many times are interest accruing loans, meaning you get this loan and you build the house and then you sell it and then you give them their money back. So it's not illegal. It's just a different mathematical system. Okay. So in this one, we already know the payment. Okay, in an interest-only loan, you notice we made this number and this number positive and negative. In an interest accruing loan, we don't know the final number. We are looking for how much this is because this and this are not going to be equal because we're giving them $0 every month. So let's do that question. So we're looking for, sometimes they do say on an interest accruing loan, how much is going to be the payment? Well, it only takes 5 seconds to figure out that an interest accruing loan means no payment has been made. No interest is being paid and no principal is being paid. Okay? And when you have this number going to 0, that means you have to pay interest for this money and part of this money. That's the only way this is going to go to 0. That's called a amortized loan, meaning loan's going to die after a particular time period, meaning loan's going to get paid off. Interest only loan means you pay the amount that's owing. This number and this number are the same. Interest accruing loan is where this number there's no payment, so this number increases to a much bigger number because no interest is being paid. The other third type of loan is called amortized loan. Fully amortized loan means this number is going to go from all the way here to 0. Fully amortized means goes to 0, dead. Okay, let's do this question. So interest rate is J1, so let's put 1 for the compounding period and 10 for the interest rate. Done. N is 5 years. We have to stay in years because this says 1 compounding period per year. 1 for the 5 for the years, right? This has already been done. PV, we got a loan of $50,000. We're giving them no money in this 5-year period. We're not taking any money from them and we're not giving them any money. So 0 for the payment. And at the end we get FV. We're looking for, we owe them $80,000. Okay, this is a mistake here. We owe them $80,000, not $63,000. But no payments during the loan. At the end, negative means we owe them. We owe them $80,000. This is a mistake. Okay, let's take a look at another one. Interest accruing loan. This time we have the interest rate J4. Let's do that. J4 means 4 compounding periods per year, 10%. N, if we're talking 4 compounding periods per year, we're talking quarters. 5 years would be 20 quarters. $5. If you want to think about $5, how many quarters there are? Those are 20 quarters. Interest rate's been dealt with. PV is 50,000. And payment is 0. We're not giving them any money. It's not illegal. It's called an interest accruing loan. Okay, 81,000 is what we owe them after 5 years. Okay, let's do interest accruing loans starting September 1st for 8 months. For 8 months now, okay? And the interest rate is J12, 10%. So the time period now is 8 months. This says 12. This says how many we have to work with months. So it's good that they told us 8 months, okay? If they had said half a year, we would have to put 6 there. Okay, so here now interest, we got the diagram. So 12 for the compounding periods, 10 for the interest rate. Done. N is 8. We're talking months. 8 months. Good that they gave us months. This is dealt with. PV, it's a loan of 50,000. We got a loan. We got money. So it's positive. And interest accruing loan means we are giving them no money. We really owed them eight payments, right? But we didn't give them any payments. Not illegal, but it was a contract saying interest accruing loan. That means we don't owe them any payments. We owe them all that interest at the end. Payment, 0. And FV, we owe them $53,000 after 8 months. Okay, let's do another interest accruing loan. Okay, which I believe we just did that, so we can skip this one. Okay, here's a question. You are offered an investment that will produce $250,000 in 5 years. If you wish to earn 4% annum compounded monthly, how much should you offer to pay for the investment today, rounded to the nearest $10? So from all this information, we look at the and we make the timeline diagram. Okay, the timeline diagram says you're offered that will produce 250. That means at the end there will be 250. So this number is 250,000 in 5 years. So this number is a 5 years. Okay, if you wish to earn 4%, so there's 4% per annum. Compounded monthly means this number is a 12. How much would this investment be worth today? So this is today. So we have our diagram. Let's see if we can do this question. Once we get our diagram, then we don't need to look at this anymore. Okay, so first thing, interest rate. 12 for the compounding period and 4 for the interest rate. Done. N, now we're talking about months. So 5 years is 60. This has been dealt with. PV, we're looking for payment. No payments or nothing's happening in those 5 years. At the end, we want $250,000 to come to us. To come to us, meaning positive. That means PV, we need to pay. Negative means pay. Even though in our answers it doesn't show negative, we just know that we need to pay $204,750. To the nearest 10 is $750. Okay, another type of question. Ready to buy a car. Okay, let's say the car is worth $25,000. Okay, we want to save $25,000 so that we have at the end of, let's say we don't know how long it's going to take. Okay, we want to know how long will it take. If we have $10,000 today, we take $10,000 to the bank. Okay, and in that time period here, we're not saving any more money. We're not taking any money from the bank account, or we're not depositing any money. We want to know how long will it take us to get $25,000 to buy this car. Okay, again, calculator comes in. Once we take this information, draw the diagram, then the calculator comes in. Now we clear everything on the calculator. First thing we do is we look at the diagram now and we put in this part. 1 for the compounding period. That means everything is going to be per years, and 10 for the interest rate. Now N is in years. Okay, this says one per year. That means N is going to be in years. N is missing. Leave it alone. This has been done. PV, we're depositing $10,000 today into our bank account. That means right here $10,000 is being deposited into the bank account. And in that time period, we're not taking any money out, or we're not depositing any money. That means 0 for the payment. At the end, we want to see $25,000 in our bank account come from the bank account. Money coming from the bank account is a positive, so FV is positive, and we're looking for N. And this answer will be in years, not months. 9.6 years. Okay. Okay, let's take a look at another question. Again, this time we're saving $15,000. Last time we only saved $10,000, and it took 9 years to get the car. Now we're doing a question we're saving $15,000, and obviously it's going to be a smaller answer. But let's see what it is. Let's see how we're going to get this answer. Okay. So first thing is interest rate is J1, so J1, and 10%. Now the answer for N is years, but we don't know, so we'll leave it. This has been dealt with. PV is 15,000. We're savings. We're putting into the bank. That means the money's going out of our pocket. Negative means anytime money's going out of our pocket to go into the bank account is negative. Anytime we get a loan, that means we get money. That's going to be positive. We're putting money away. So PV, payment 0, and FV is 25,000, and we get N is about 5 years, a little bit more than 5 years. Okay, another question. We're ready to buy a car, and the car's value is $25,000, and we have $15,000 that we just put away, and we want to know, are we going to have enough money to buy this car in 5 years? And the interest rate is J1, which is per annum, with one compounding period. So J1 equals 2%. So we draw the diagram. Okay, we're looking for FV. Okay, we want to make sure the FV is 25,000, but if we put 25,000 here, we won't be able to answer this question. Okay, the question is, how much money are we going to have in 5 years? Are we going to have enough money? So do not put $25,000 into the calculation yet. Okay, so our diagram looks like this. We have 15,000 put away now. In the 5 years, we're not doing anything to that bank account. We're not taking any money in, and we're not taking any money out. So let's do the question. So 1 for the compounding period, 2 for the interest rate, done. N, we want this car in 5 years. This is years also. 1 compounding means years, so leave it alone as a 5. This has already been dealt with. PV, we have 15,000 today. We went to the bank and deposited it. That means money went out of our pocket. In the 5 years, we're not depositing or taking any money out of the account, and we find FV. FV comes out to be 16,000. We want it to be 25,000. That means we are short some money. So the answer to your exam question is, you take your 25,000 and subtract 16,000, this number, and that means we are short by $8,438. Okay, this question can be done differently, and that is, how long will it take to get 25,000? Then you do put in your 25,000 here, and then you press N. This says 25 years is what it will take to get yourself to from 15,000 to 25,000. But the question isn't how long. The question is, will you have $25,000 in 5 years? So the way to do that question is this way. Put in the interest rate and put in the rate. First was compounding period. N is 5 years. PV is 15,000. Payment is 0. And press FV. This tells us how much money we will have. Then we need to subtract from 25,000. That will tell us how much money we are short. Okay. Okay, what if we only have $10,000 and the interest rate's 10%? Are we going to have enough money? Let's take a look. Okay, again, the question is the same. Actually, the question is a little bit different now. The question is, how much money do we need to save every year? How much money do we need to save every year so that we can buy this car in 5 years? Okay, car value 25. Now we have $10,000. We want to know how much we're going to save or we need to save every year to buy this car in 5 years. So let's set this diagram up. You see this diagram? Interest rates given, time is 5 years. We have 10,000. We want 25,000. Payment is how much we want per year to figure out. Okay, so 1 for the compounding period, 10 for the interest rate. N is what? 5 years. This is done. PV. PV is 10,000. And FV is 25,000. And payment. Every year, if we can save another $1,456 from our pocket, negative means saving and putting away, then we will have $25,000 in 5 years. Okay, let's say the interest rate is J12 equal 10%. J12 equal 10%. How much payment every month do we need so that we'll have our money to buy this car? Okay. Okay. Let's do this question. Okay. Okay. Okay, car value 25, savings 10,000 today. We want to know savings per month. Okay, how much to put away per month? Interest rate is J12, so great. We're talking about months. Interest rate is 10%. N is 5 years, but we're talking months now, so we need 60 for N. Interest rate's been dealt with. PV, we have $10,000 today, and we went and put it away, 10,000. PMT is what we're looking for. That answer that we get afterwards is going to be how much money we need to put away every month, and we want to have $25,000 in our bank account afterwards there, and this number $110 per month. We need to save $110 per month to buy the car after 5 years. Okay, another question. The question now is, what interest rate would allow us to get from $10,000 to $25,000 in 5 years? And in those 5 years, we're not making any savings. So what interest rate? So let's figure out the interest rate. And interest rate, we're talking years, so we're only going to be able to find J1. So first thing, we do know the one portion, but we don't know this portion. We don't know the nom portion. So 1 for the interest rate, 1 for the compounding period, and now N is 5, and this we're looking for. PV is 10,000, and payment is 0. At the end, we want 25,000. And we're looking for interest rate, 20%. Okay, you notice I didn't press second nom. If we press second nom, for some reason this calculator doesn't work. When we're looking for the interest rate, we just at the end we press white button I per year. Okay, let me show you what I meant. Okay, so 1 we know, 1 portion we do know. Okay. And the N we know is 5 years, so 5 for N. Interest rate we're looking for, PV is 10,000. And F0 for payment. FV is 25,000. And if I was to press second function nom, I believe it gives me an error. I need to press just the interest rate per year to get the answer. Okay, be careful with that. That's a flaw in the calculator. Okay, let's do another question with interest rate again. This time we're looking for what is our J12? Okay, and again we want to save from 10,000 to 25,000 to buy the car, and what is the compounded monthly interest rate? Okay, let's do that. So 12 for the compounding period, and N would be 60, because we don't know this part, right? We left it alone. So we're going to come back and press that. And be careful when you're looking for interest rates, pressing second nom doesn't work in this calculator. PV is 10,000. PV. And 0 for payment, and 25,000 for FV, and our interest rate is 18.46. You notice here we want to go from 10,000 to 25,000 in 5 years. This J12 came out to be 18.46, but when we calculate J1 here, it came out to 20. That means this J1 of 20 must be the same as J12 of 18. That's what it's coming out to be, that it must be the same. Okay, so if we look at that, we're going to, next chapter, we're just going to get into that
and figuring out what are these interest rate, those 12 and the 1 number for the compounding period is all about. So this chapter is all about getting used to the calculator. Okay, let's do a few more questions. Okay, so keep in mind PVs and payments, positives and negatives. Think about when you're borrowing or when you're getting money. When you're getting money, PV is positive, and probably you're giving loan out, payment might be negative, or if you're getting more, then payment is still positive. But when it's for the lender giving money, or when you're depositing money into a bank account, PV is negative. For now, just think about that. PV is negative.
So for chapter
Okay, let's do
13,
question number
part
3.
We're going to do a few
An interest-only
examination
loan
type
of
questions.
$560,000.
Question
Calculate the
is,
amount of the
Joe wants to
quarterly
buy an investment home and
interest-only
wants to hold it
payment
for
if the
15
loan
years.
term is 5
He
years
wants to earn
and the
7%
interest rate is J4
interest
equals
per annum,
9%.
per year,
Right away, timeline
and
diagram.
J1 equals
Put in
7.
our interest rate,
What is the
J4
maximum
equals
price he should
9%.
pay for the home
5-year
if he will
loan,
sell
so
for
5
$1
times
million
4 is
in
20,
years.
so it's
we
20
read all
quarters.
we make our timeline diagram.
Loan amount is
And on
PV
the
560,
timeline diagram, we
and
put in
the
information
question
we have.
isn't
We
going to
have
tell you to
J1
put in
equals
FV
7%.
also 560
We
with a
have
negative,
15
but
years.
you need to know how to
We
do
are
it. You
looking
need to do
for how
that.
much, what is
And
the
we're looking for the
maximum price he
payment.
should pay
Okay, so
today
payment, quarter
for the home.
payment,
So we're looking
quarterly
for
payment
PV.
every 3 months.
Payment
The
is
choices
0.
are here.
At the end,
And
we
what
want to
we're
sell
going to
this
do
home
is
for
we're going to bring in the
15
calculator
years
now.
For $1 million. So we want $1 million
And the
coming
first
to us.
thing we do is
So
clear
that's a
everything
positive
on the
number.
calculator.
In the
Put
15
in our
years, no money is
interest
going
rate,
in or
4
out.
for
In reality,
compounding period,
obviously, we would
and
want
9
expenses
for the
this
interest
house,
rate.
but it's more of
That's done.
arithmetic question.
N
Okay, so we're
N
looking
is
for
20
PV,
quarters.
So first thing we do is here's the choices.
Done.
Then
This has been done.
Now we bring in
PV
the
is
calculator.
560,000.
And here's a calculator. So we start doing the arithmetic.
Also, FV
first,
is 560,000. I don't have to type it out again. I can
the
just put a
nominal.
negative here and put it
1
in
for
as
the
FV
compounding period
and
per
come
year,
back and find
and
payment.
7 for the
Payment is
nominal
12,600 every
N
quarter,
is
meaning
in
every
years, so
3
it is
months.
set up
So I
15
believe
years
the
here.
answer is B.
Done. This is done. PV we're looking for.
So
Payment is
12,600 every quarter. The answer is B.
FV is 1 million.
Let's do another question.
Positive 1 million.
What will be the third monthly payment
And we're
of a
looking for PV plus
$255,000
FV,
interest-only
negative
loan
we have to pay
with interest rate of
$362,000.
0.5% per month? So from 0.5% per month, if we multiply by 12, we will get our J12, and J12 will be 6%. Okay. So first thing, timeline diagram, put in our interest rate. J12 is 6%. 0.5% per month is the same as 6% for the year. Okay? And again, they didn't tell us about the time period. It's not important that we know the time period. Interest-only loan could be any time period, and we'll be able to get the answer. Okay, 255 is the loan, and again, 255 for the negative. This means we get, this means we have to return the same amount because it's interest only, it's renting only. We're not getting to reduce the principal and looking for. Okay, so these are the choices. Now we bring in the calculator and clear everything on the calculator. First thing is 12 for the compounding periods.
So these are the choices.
And then 6 for the interest rate.
We're going to now bring in the calculator.
Oops, I need to put in second function. Let's go back again. Okay, 12 for the compounding periods.
3 years or the 2 years. So the last payment
and 6 for the nominal interest
here,
rate. N is, I'll just put 1 for N, thinking it's a 1 month loan.
And
Okay.
5 for the interest
This
rate.
one's done. PV is 255.
N is 2 years, so it's N is 4.
Oops, made a mistake there.
And I'll do the same.
255,000 is my PV, and also 255,000.
Accruing loans will that time period make a difference?
Didn't feel like saving time.
Interest rate's been done.
Is my
PV is
FV,
300,000.
and my payment every month will be 1,275. Looks like the answer is
And
A.
also FV is 300,000 with a negative. And we're looking
All
for
payments is the same.
payment
So if they're
every
asking
6
for the
months is
third monthly
$7,500.
payment,
Every
we could have
6 months
went
is
back and said,
$7,500.
put n equals to 3, and that would also give us the same here. I will bring back the calculator.
Will be 300,000.
Okay, so I can put 3 for n.
So my answer, I believe,
and press payment, same answer. It doesn't matter how long this loan is.
Negative 7,500.
So the answer is 1275.
Every 6 months. So the
last question. Interest accruing loan. Interest accruing loan of 250 started with a term of 8 years. Interest rate 4.5% per annum, compounded monthly. That means J12 equals 4.5. Calculate the amount that will accumulate at the end of 8 years. So first thing we do is draw the timeline diagram, put in our interest rates, put in our time. So we are going to need to know how many months is 8 years. So 8 times 12, that's 96. Loan is 250. Payment, no money's going in or out. That's what an interest accruing loan is. Payment is 0 for an interest accruing loan. And we're looking for FV. So bring the calculator and clear everything. And put in our compounding periods, 12 compounding periods per year. And 4.5 for the interest rate for the year. Done. N is 96. So we need to work with months. And this is done. PV is 250,000. We got a loan of 250,000. That means it's positive. We got the money. Payment, there's no payments being made in that 8 years. No payment going in, no payment going to the bank. And at the end, we have FV is $358,000. So the answer, I think, is the first one. There you go. Okay, last example for chapter 13, part 1. John got $350 from his mom as a gift. He wants to use the money in 3 years to pay for a helmet, which will cost $1,000. John has deposited this money in a savings account bearing a periodic interest rate of 0.5% per month. So periodic interest rate is interest rate for a period of 1 month. So from this, we can multiply this number by 12 and get interest rate for the year. And now this bottom number is a 12. We're going to talk a lot more about conversions and so on in the next part of chapter 13. Will John have enough money to pay for the helmet in 3 years? If he will not have enough money, how long will it take John to save the $1,000? So 2 questions in here. So let's first draw the timeline diagram. Interest rate, J12 equals 6%, and N equals 3 years. Okay. He has $350 now, and he's not going to save any more money in those 36 months. He wants to make sure he has $1,000. But be careful, we do not put the $1,000 part into the calculator. We find the FV. We find the FV. Okay, so these are the choices. We bring the calculator. Clear all. And we're going to find the FV. See if it's $1,000. If it's $1,000, great, we can buy the helmet. If it's more than $1,000 FV, that means we have more than enough money. If FV comes out to be less than $1,000, that means we do not have enough money. So let's do the question. 12 for the compounding periods per year, and 6 for the nominal interest rate. N is 36 months. This is done. PV is $350. We say we got, but then we put it into the bank account, so it's a negative number. 0 for payment, and FV comes out to 400. Well, that's all we're going to have after 3 years. We're only going to have $418. That means the answer to this question is $418 is what we have. But we are asked how much are we short. So we need to take $418 away from 1,000, and that gets us $581 short. And also we want to know how long it would take to get this helmet. So this, we know the answer is 581. So most likely the answer is 210 months. But let's go back and bring the calculator. And we want to do the second part of the question. Second part of the question says we want to have $1,000. So I'm going to do this the fast way. We're going to have a FV 1,000, and we're looking for N. 210 months. But the slow way or the tedious way of doing this question would be, if we're trying to find the N to have $1,000, so then we put in the interest rate, compounding 12 times, and the interest rate is 6%. We're looking for N. This is done. PV 350. And 0 for payment. FV, we want to have $1,000. And we're looking for N. 210 months. So that's our answer.